So welcome, ladies and gentlemen. In this video, we're going to be talking about area and volume. And the figures and solids that we're going to use are based around a circle. And specifically, we'll be looking at a circle, a cylinder, a cone, and a sphere, which are all based around the formula for a circle. Okay, so area of a circle equals pi r squared. So r squared, anytime we have a variable that has a power of 2 on it, we're basically dealing with 2 dimensions, and we'll talk more of that as we go through this video, where we get our dimensions from. So dimensions, so somewhere I have kind of like a length times a width, like I would with a square. Now with a circle, we know that the dimensions are based around a radius, and I'm going to have a radius going up, and I'm going to have a radius going to the side. Those are each BR. Now when you take a look at a square, which is kind of like a circle, I have all the sides that are the same, just like the radius is the same, so S times S will give me S squared, which is an area, so I have 2 dimensions. And we treat those sides just like we would multiplying 2 variables together. X times X would give us X squared, so that's where I get the S squared. Now if we look at the R, I have R times R, gives me the R squared, and I have dimensions with this. And if you look at this, we're dealing with a circle again, and I have to give the dimensions, and the dimensions are based around a kilometer, km. So when I get done with this, my units will be km squared, because km times km will give me km squared. Okay, so we're dealing with a circle, and now I have to find the radius. It's pi times r squared. So to find the radius, sometimes you're given a diameter, sometimes you're not. You're just going to have to read the problem and look at it. So, and we have to convert that diameter to a radius. So in order to do that, we are going to divide it by 2. So 14 divided by 2 obviously will give me 7. So r equals 7. So pi 7 squared will equal the area 153.9 kilometers squared. Now some of the things that I'm going to need right here is I need to see the formula. So you need to write down the formula that you're going to use. You're going to show me your calculation of the value for the volume to 1/10, and then I also need your units, which would be kilometers squared. So those are the things that I need. Okay, the next one right here, we're going to be dealing with a cylinder. And if you look at this cylinder, I can see that the diameter is 22 feet and the height is 15 feet. H is 15. So you can see this is based upon a circle, because if you look at the 2 ends, you can see that it's at 2 ends. And basically what happens, I take, let's say we take the bottom and I stretch it up to the top, and that's what gives me the height. And that's what turns it into a volume. We know we have r squared, which will give us 2 dimensions, and that 3rd dimension is given by that height of 15. So the radius on this one is 11. And so 11 feet. And the formula is based around the idea of a circle. So you can see the pi r squared, and then I have that one more dimension, which is h. So feet, there's 1 r. The other r is also feet. And then you have that 3rd dimension, that is h. So there's another feet for h. So that will give me feet cubed for that r squared times h. There's our third dimension. That's what gives us a volume. If that h wasn't there, all I would have is the top circle or the bottom circle to that can. So that tells us that we're dealing with a volume, is that exponent of 3. Okay, let's go ahead and find the volume here. So we have pi, r is 11 squared, and then times it by h, and h is 15. We'll go ahead and put that on my calculator. Pi times 11 squared Okay, so my calculator, I type it all in and I get 5,701. I'm going to round that off to 5,702. So our volume is 5,702 and our units are feet cubed. Okay, now we're dealing with a cone, and what I want to show you is how we get the formula for a cone from the formula for a cylinder. So I'm turning this cone into a cylinder. You can see that we have a circle at the top, we have a circle at the bottom, and then we have our height that gives us the volume that we need. So we're going to be dealing with the area of a circle, and somehow we have to cut all that excess off the sides and the top. It has to be cut away, and that will actually be built in the formulas. So we want to keep the insides. So the area of a circle is pi r squared. And we know that to turn that to a cone, or to turn it to a cylinder, we times it by its height. So there's the formula for the volume of a cylinder. And now we have to cut away that outside stuff. And to do that, all we need to do is to divide by 1/3. And if we divide by 1/3, it cuts away all the outside, and that 1/3 keeps what's inside the cone. So 1/3 pi r h will be our formula. And now we have to find the radius. So 1/3 pi times 5 squared times the height, which is 10. And now I'll go ahead and get my calculator out and we'll times all this together. So I have 1 divided by 3, so that keeps just the cone, cuts everything else away, times pi 5 squared times the height, which is 10. And now I get 261.8 if I round off to the nearest 10. So let me go ahead, write that number down so I can remember it. And remember our units is centimeters. So remember we have a centimeter for the radius. We have a centimeter for the other radius, because r times r. And then we have a centimeter for the height, and that's going to give us centimeters cubed for our units. So our final answer for the volume of this cone will be 261.8 centimeters cubed. So in this last section, we'll be talking about a sphere, and a sphere is also based on a circle. That's been kind of our theme, dealing with volumes that have to deal with circles. Now what I've drawn here is we have a cube, and I want to show you how a cube and a sphere are related. We know a cube has all the same lengths for the sides, so the length will be s, the width will be s, and the height will be s, and that will be a cube. So if I take s times s times s, it's going to give me s to the third power, correct? Well, if you remember with a circle, I had pi times r squared, and that squared came because if you take a square, length times length will give me L squared, well R squared will give me the same idea that we go back to that circle. So let's use that same idea with the sphere. R to the third brings in the cube, the pi brings in the circle. Now there's something that has to be missing there at the top because all we want is the sphere inside the cube. We don't want the entire cube. So what do we have to do with that? That's our next question. Well, here's the idea. To remember the cylinder, the formula for the cylinder was pi r squared h, and there's our 3 dimensions. We have 2 radiuses in the height. And then we had the cone. And the cone was based on the cylinder. But remember what we had to do to the very beginning of it? We had to multiply it by 1/3 to get that cone out of the cylinder and just keep what we wanted out of that cylinder. And that was that pyramid or that cone piece that was on the inside. Well, inside this cube is hidden that sphere that I want. Well, the same idea takes place. Instead of multiplying it by 1/3, I'm going to multiply it by 4/3 or 4/3. That is the formula for a sphere, for its volume. So do you see that connection to the cone and to the cylinder and to the cube? It all connects together, doesn't it? So that 4/3 keeps the inside that we want. The pi brings in the circle, and that r to the third brings in the cube and ties all those ideas together. So let's go ahead and figure out the volume now. I think we need to find the radius. We haven't found that yet, have we? Now remember the diameter is 24. To change a diameter to a radius, I divide it by 2. So that will be 12. So 4/3 pi, and then my radius is 12, so 12 to the third power, kind of a nice simple formula. Bring up my calculator and we'll go ahead and plug this in. 4 divided by 3 times pi times 12 raised to the third power. And I get 7,238.2. So 7,238.2. And then my units will be in centimeters. So centimeters cubed will be my units. So now remember, as you do these problems, that you've got to make sure that you show me 3 things. First, I need to see the formula. I need to see the value of the calculations, and then I need to see the units. So that's it for this video, and I really appreciate you watching, and thanks.